Hi, I'm Mercy, and this is the place where we try to answer all your science-related questions. It's the one-stop science shop. We have a question already. It's Ahmed from Indonesia. His question is, what's the difference between reflection and refraction? Great question, Ahmed. I'll prepare something fantastic to show you. First of all, the simple answer to Ahmed's question is that reflection is when light falls on an object and bounces off, whereas refraction is when light bends when it's passing through an object. Have a look at what I got. I have some water in a jar, regular cooking oil, a couple of empty glasses, and a glass stirrer. Watch what happens. Did you see that? The stirrer seems to be bent when I put it in the water. Now watch what happens when I do the same thing with oil. And the stirrer. Did you see that? The stirrer seems to disappear right before our eyes. Now let's see what happens when I mix the two. We'll wait for this to settle. First of all, what happens when they separate? The oil floats to the top. This is because oil is less dense than water. Let me put in my glass stirrer and see what happens. We can normally see a glass object because it both reflects and refracts light. But light travels at different speeds in different liquids. So when we put a stirrer in water, the light bends slightly, making the stirrer appear bent. And when I use a heavier liquid, like cooking oil, the light bends furthermore. So much so that at one point, it does not even get out of the glass. With no reflection and no refraction taking place, the object gives off the illusion of becoming invisible, thus making the spoon appear to disappear. To see for yourself at home, here's what you need. Water, cooking oil, glasses, and a glass stirrer. We just learned how to spot the unusual in the usual. Let's see who's gonna visit us today. Hi, I'm Mercy. Come on in. Welcome to the one-stop science shop. Who are you?
I am Totrinya.
Hello, Totrinya. How old are you?
I am 11 years old.
And what grade are you in?
I'm the 6th grade.
So what's your favorite subject in school?
Spanish.
Why?
Because it's a new language.
Okay, can you tell me some words in Spanish?
Hola, which means hello. ¿Cómo estás? Which means how are you. ¿Cómo te llamas? Which means what do you call yourself.
What about sports? Do you like sports?
My favorite sport is football.
Okay, and who's your favorite footballer?
Messi.
Did you say Mercy or was that Miss?
Messi.
So what brings you here today?
I wanted to learn about light and reflections.
That's a wonderful topic, and I have something really interesting for you right there. This is Zhang Han, born in 7880. And no, he obviously didn't have a beard when he was born. Right, his birthplace was the town of Jie, at north of the modern city of Nanyang in Henan province. His family were administrators and civil servants, but sadly, when he was 10 years old, Zhang's father died, and he was brought up by his mother and grandmother. They had him trained not only in mathematics and the sciences, but also in languages and the teachings of the great philosopher Confucius. Zhang grew up to be a renowned scholar with a flair for poetry. The emperor King An hired him as a civil servant to his court. However, instead of doing his work, he often spent his time composing long epic poems. Naughty Zhang. The emperor's court, though, was full of influential people including the mathematician and calligrapher Shui Yuan and the philosopher Wang Fu. Mixing with so many talented scholars and thinkers motivated Hong to put epic poems to one side and study astronomy. He constructed a spherical model of the known universe to study and chart planetary movements. Hong wrote a book called The Spiritual Constitution of the Universe, where he talked about radiating influence theory as a way of explaining solar and lunar eclipses. Hong noticed that the moon is like a mirror. When illuminated by sunlight, it reflects some of that light back. Due to this reflection, it appears to shine. It's so bright that it is the sole source of Earth's natural light during the night. But when the moon is highly illuminated, it reflects so much light we can even see it from the Earth during the day. Zhang was awarded great honors due to this and other discoveries. Being a civil servant, his salary was increased tenfold. After he died, a tomb was erected to commemorate him. His work was so influential that several things have been named after him in modern times, including the lunar crater Zhanghe, the mineral Zhanghengai, and the asteroid 1802 called, wait for it, Zhanghang. None of this would have happened to him if Hong hadn't hung out with the right crowd. The world of epic poetry's loss was definitely science's game.
So Zhang figured out that the moon was like a mirror reflecting back the light shining on it.
Yes, and sometimes we can use that to trick our eyes into seeing things that aren't really there.
Like thinking that the moon gives out light?
Exactly. Do you want to do something which fools our eyes?
Yes, of course.
Great! Let's see what we've got in our one-stop science box.
So let's see what we have here. An empty glass bottle, or say a transparent bottle, an empty candle spindle, CD spindle, some sheet of chart paper, some stationeries, if you want you can use a pencil and an eraser and a sharpener along with the pencil. Wait a minute, what are these strips of papers doing here?
But that's the template for a zoetrope.
What's a zoetrope?
A zoetrope is an optical toy consisting of a cylinder with a series of pictures on the inner surface. When viewed through slits with the cylinder rotating, the pictures come to life.
You mean you can move the unmoving?
Yes! And now let me get this out of the way so that we can get started on building our zoetrope. First of all, I'm going to remove the part of the CD cover that we're not going to use.
Why don't we need it?
We just need the spindle for the base of our zoetrope. So I'm going to put that there, alright? And now we have to cut out the chart paper to a strip of 9 centimeters wide, approximately 45 centimeters long. This is going to be part of the outer area of our zoetrope. Alright, 9 centimeters here again. Oh, that's too far away. Okay. Now, let's mark out our 45 centimeter strip at regular intervals of 3 centimeters for our viewing slits.
15.
Now, can you cut that out for me, please?
Oh yeah, sure.
This will form our viewing slits. Okay, we're almost done.
Yes.
Now we're gonna see how much of the strip we need.
And are we going to cut out the remaining?
Yes, we'll mark it out, cut out the remaining. Now we have to glue this together.
Oh, I can.
Great.
Is it done?
Yes, I think we're good to go, yes. Our cylinder is ready. Let's have a look at our template. This is a template I've pre-cut. I've downloaded the images from the internet, but you can also draw out your own template, okay?
All right.
Let's see how it works. You have to roll it a bit and fit it into the zoetrope.
What about the images which gets covered?
You make sure that it doesn't get covered. This one's fitting right in. So Trina, do you want to come and see? Look through the slit with your eye.
Yes.
Can you see the images?
ma'am.
All right. Now watch this.
Ooh, look, they're moving.
Can you see the man with the hat?
Yes.
Can you see what it's doing?
Is he falling?
Well, he's taking a bow with his hat.
Oh.
It's fantastic, isn't it?
Yes.
If you want to make your own zoetrope at home, here's what you need. Empty glass bottle, empty CD spindle, chart paper, some stationery, and your zoetrope template. Here are some examples.
This zoetrope is so cool. Can I take it home to show my friends?
Of course! And don't forget that you can make so many more templates. You can even draw your own and make some crazy animations. Thank you, Tatrinia. It was wonderful having you here.